So what Abby did here was she just broke up her shapes. She saw that those are squares, so we want area of the square. And then we had area of a triangle, and then we recognized that all the triangles are basically the same, so it's just 4 times the area of a triangle. So here we got 8 times 8, which is the area of a square, 64. Take out the area of one of the triangles. Now this one was easy, right? Because we're given the base, it's implied, the side of the square, and we're actually given the height, right? So you didn't have to do the Pythagorean theorem like we did last class, right? Really, last class, the hardest shape to calculate the area of was the triangle, because there's lots of steps to get that height. But here we're given the height, so we got 8 times 10 divided by 2, gives us the area of all the triangles is 160, add it all together, you get 224, and she put the units there, centimeter square. Awesome. Good work. Any questions on that? Like what steps?
I just wrote area, and I wrote like the formulas, like 90 times width, and then I wrote equals 64 plus 160 equals 224. I think that's good.
I mean, you can simplify this part into one step if you like, right? That's fine. I would probably go from this step because at least these numbers, you're telling me that you're plugging into your formula, right? And if you went straight from here to here, that's fine. But what happened is you went straight to this point, and I saw those numbers and they were wrong. I have no idea how you got those numbers. That frustrates me as a teacher trying to mark and understand what you're doing, is that I don't know how you got those numbers. Right? So at least you can tell me you got the formula, what numbers did you use to replace that formula. So that tells me that you understood what the base was, what the height was, etc., and I give you credit for that.
And do you have to write area equals area square plus 418, or do you just go straight to like times width plus 418?
Either one will work.
Okay. Thank you.
So I have a question for you. If I was to take this thing, two-dimensional figure, cut it out, fold it up, what do you think I would actually get? I don't know, Matt. What would you get?
Square-based pyramid.
A square-based pyramid. So what did we just actually do?
Oh, this is a net.
What's a net?
A net is a layout of the flat shape.
Oh.
You just take it and just stick on it.
Oh yeah, two-dimensional.
Okay, good, yeah. So two-dimensional representation of a three-dimensional figure. Right? So without realizing, or maybe you did, you just calculated the surface area of a three-dimensional shape, which is what we're talking about today. Okay, so I want to go over this quickly. I don't want to go through a lot of time in explaining the formulas. That's just something that you sort of have to memorize. Okay. Hopefully, as we talk, you draw the net, you get an appreciation where the formula comes from. All right. Get an appreciation where the formula is coming from. So here, the surface area. Well, let's start with the pyramid because that's what we started first. So the surface area is really, we take the number of sides. So this is a regular. Your base is a regular polygon. So you take the number of sides, multiply the length of the side. So S is this is the length of a side.
Oh, ours? Yeah, we have a different pyramid surface area.
Got outdated and I couldn't write it down. I couldn't print it off in time. So you can write down this other formula if you want.
Wait, what?
Can you write it out?
Wait, is that the same thing as the other one?
Could you write it on the board? I can't really.
Can't really see it?
Wait, so the pyramid one that we have.
No, it's right, but you can write this as well. And this, I want to help you understand where this comes from. So it's the number NS is the number N is the number of sides. S is your length of a side times A over 2. So really that's the area of the base, right? The area of a regular polygon. In other words, it's the perimeter times the apothem. Thank you. Apothem. And so we saw what Abby did with the triangles, it's the number of triangles, which is the same as the number of sides, times the side times its L divided by 2. So L is our slanted height of the pyramid, which turns out to be the actual height of our actual triangle.
So SL stands for slant.
Yes.
So for n times SL, do you want us to do SL over 2 first?
Just have that first. This is where you actually get that formula from the having sheet. Okay? Because really, what is n times s? So we have the number of sides, and s is the side length. What is n times s?
X times however long.
No. N times s.
Number of sides.
So we have like
NS.
a hexagon. So this is s, and it has 6 sides. What's n times s? Yeah, it's just the perimeter, right? So perimeter is just the number of sides times the side length, and that's where you get your formula PA over 2 plus PL over 2.
So perimeter times apostole.
Yes. S is short for the side length.
Perimeter times apostole.
S is the side length, L is the slant height of a triangle. Okay. But we're just seeing that NS. And the reason I put this formula down is how often you actually given the perimeter. No, we usually tell you the length of the side, right? So this is just another version of this equation because perimeter is equal to the number of sides times the side length. Okay? The volume of a prism or pyramid, sorry, is 1/3 A. A is our out. No, it's the area of our base. So A is the area of the base. Yeah, what they said. Apostome lowercase. And remember when we did the rearranging of formulas way back in the equations unit? And I said you can't switch lowercase to uppercase and uppercase to lowercase. You need to keep it the same. And hopefully we're starting to understand why. It's because even upper lowercase variables have different meanings. So here we see uppercase A is area, lowercase is the apostome. So this is A is the area of the base.
Is that point like an AH?
The A itself
Oh, the
is
A.
area of the base, which is PA over 2. Right? This is really PA over 2.
You want us to draw the net for the
You can draw the net for the pyramid, which is basically what we just did. That was a warm-up. Here you have it figured out by now. All my art consists of stick figures. Okay, so let's go back to the prism. So the prism for, let's say, a square-based prism, the net looks something like this. No, you can just start with the square. I think we deal mostly with triangles and squares. Okay. But the idea is that the number of those rectangles that you have in the middle, what is that equal to? Yeah, it's the number of sides of our base, right? So here, the number of rectangles equals the number of sides in the base. What is that side length? There. So So if I put all 4 of those rectangles together, what is that length really? Yeah, it's just the perimeter of our shape, right? And so this is where we get our surface area from. So PA, this is just the area of the base. Right? That was from our formula. Actually, the area of the base is really PA over 2, but because of the prism, how many bases do we have? We have 2, so that gets rid of that fraction divided by 2. So we're just left with PA. PL, the perimeter is just the circumference of our base. Or sorry, the perimeter of our base. L is this part, right? L is just our length. So notice that we're just really calculating the area of a rectangle. And that's where we get our equation PL from. Where we have the length, which is how long a prism is, but the other side of this rectangle is actually the perimeter of our base. And I wish I had some physical things that prisms that actually unravel for you. When we see unravel, you can actually see it's an actual rectangle. Did you have those last year?
Yeah, it's like.
So we have to steal them from Mr. Stevens then.
Mr. Davis.
Oh, Mr. Davis.
Elephant.
Mr. Davis with the cylinder head.
So the volume, again, perimeter times area, so it's just the area of our base. We just multiply it by the length of our prism. That's how we get the volume. Okay. P stands for perimeter. Perimeter of the base. So really, I should change my notes. I should put B's underneath all these. And these are B's. Just to make it clear that we're talking about the perimeter of the base. Because in reality, there's lots of perimeters, right? In our three-dimensional shape. So really, it's really the perimeter of our base. Okay, surface area of a cylinder. Seems like you guys have done this before. Sounds like it's mostly review. So surface area of a cylinder, again, this. Pi r squared. What's that really the area of? The circle, right? But because we have 2 of them, that's what we multiply by 2. What's that?
That's
The round.
the actual cylinder.
No, like the rectangle.
I was going to say, all we're doing here is another calculation for a rectangle. What's one of the lengths of a rectangle? It's the height of a cylinder. So that's one length of a rectangle. And the other, the other length is just the circumference. And this is where we get the circumference from, right? So how the net for this looks like is just something like that, right? So hopefully you get a little bit of understanding where these equations come from, because if you don't remember the equation, which happens to me a lot, you can decipher. In other words, you can start figuring out for yourself, hopefully by just looking at the shape. For now, yes. The only one that really doesn't make sense is the volume of a pyramid. So that one you just, how about just memorize it? How can I rewrite this equation? PA plus PL. I can factor out a P. So I would do just apostrophe plus length, put down my calculator first, and multiply the perimeter. In other words, I only type in the perimeter once. That's how lazy I am. You're usually told the apostrophe. Well, okay, what's the apothem?
It's like a radius of not a circle. Yeah.
What's the apothem of a square?
From one end to the center.
It's from the center to the edge.
So if that was 4 centimeters per hour.
So it's half the side length. So the example, right? Just going through and plugging in our formulas. So what's the surface area?
So PA or P times plus P over 2.
It's not over 2. This is a.
Oh, sorry. The pyramid is over 2.
So again, we see that relationship. This is the same formula for the prism. Pyramid. So basically, a prism is twice the surface area of a prism.
Gotcha.
Or a prism is half the surface area. A pyramid is half the surface area of a prism.
Why?
Well, it's easy because if you think about it, in a prism, you only have one base. Sorry, you have 2 bases.
But
In a pyramid, you only have 1. You take your face, and you make a triangle out of it instead, you actually get half of that surface area.
That makes sense.
Okay?
How do I P out? What's perimeter length?
So what's the perimeter of this figure?
How do you roll the net there?
Oh.
6 times A. 6 times 4 over 2.
The net of what? The net of this will look something like this. You have your hexagons and then 5 of these.
It's not a pentagon.
This is a pentagon. Sorry.
Oh.
And then something like that.
What's the perimeter be 6 times 10?
Yeah, the perimeter is the number of sides, which is 5, times the length of each side, times 6. The Potham here is 4, plus 5 times 6 times 15. So 5 times 6 is my perimeter in both cases. My Potham here is 4, and then the length of my prism is 15 centimeters.
Got it.
6 centimeters.
Oh, okay.
That's my side.
15. Oh,
15 came from my length
oh, yeah.
of my prism. Right? So we got 30 times 4 is 120, plus 30 times 15 is 450. So that's equal to 570 centimeters squared.
Is it
Area we're talking still centimeters squared. Yeah, it's just the face, right? We're just talking about the, no, not the face, the base.
Yeah, that's what I.
And these are faces. Okay. So we got the area. Area is just the perimeter. That's the Potham. That's the length. So here the perimeter is 5 times 6 again, times 4 times 15. 1,800? Okay. So prism is pretty straightforward, pretty easy. Volume's always cubed. Sorry? Oh, sorry, yes, B. Thank you, Mike. Cylinder, both. So I'm going to let you guys do that because you guys have your equations. A pyramid. This one I want to take up a little bit because this one's tricky.
Wait, did we skip the pyramid?
We're skipping the cylinder because it's just
Oh, yeah.
applying our equation. So this question, what are we given?
Given the slanted height. The height. Wait, is that the slanted height? Oh, that's the height. That's the height.
Yeah, it sounds so weird.
The height is the
So that's the height of the pyramid. So let's calculate the area first. Sorry, the volume. So the volume is 1/3. Yeah, because that's the easier one.
1/3
A, H. It's easier because we're actually given the height, right? We're actually given the height of our pyramid. That's equal to 10.
What's A again?
A is our area. So what's the area of our base?
100.
10 times 10. And then
square.
it's a square base prism. I mean pyramid. And our height is 10. That's Gabriel?
So what would the 10 at the bottom be?
This 10 is for these side lengths here. Okay. Is it not coming out clearly on the? Yeah. Because the side length is 10, because it's a square, we talked about it already, a path is just half the length of the side length. Half of the side length, which is just 5. So here we got 1,000 over 3. So what's that? 333.33 centimeters cubed. Sorry? Yeah, you can put the repeat sign if you want. Okay, so the volume is straightforward. What's a lot harder in this question again is going to be the surface area. You gotta leave it in decimals like that, or you can just leave it as a fraction. 1,000 over 3 is the exact answer. Okay?
Wait, do you want us to repeat it?
You could try repeating, or you could do the 0.33. Okay, so how do we get the surface area? So you go to PA. So the perimeter is 4 times 10. No, it's a square base pyramid. So it's 4 sides. Each side is 10 times the apothem, which is 5. So plus, perimeter is 4 times 10. Right, so it's perimeter again. But what's the length?
We have to do the Pythagorean.
So what is it that hopefully that you're trying to see is that, and it's hard to see in a two-dimensional drawing, is that if you have the apothem here, which is 5, and this height, so it's going down from the top of our pyramid straight down, so we're looking inside, it creates a right angle in here with the ground, so to speak. So if we want the, and I'll draw this in blue, sort of like our slant, which looks like that, we get a right angle triangle. Right? So this happens to be which part of the triangle? The hypotenuse. Right? So here what we have is L squared is equal to A squared plus B squared.
So,
Right? If I'm going to label this L. So L squared is equal to,
10.
doesn't matter which one, so 10
squared
plus 5 squared. So L squared is 100 plus 25. So L squared is equal to 125.
No, it's not 15. 15 is 225.
So square root of L squared gives us L. Square root of 125?
11.18.
11.18. Okay. So that's the tricky part about calculating the surface area of a prism. You either given the L, or slant height, or you're given the height. But chances are you're not going to give both. So you're going to have to use the Pythagorean theorem to calculate one or the other. So we'll go back and plug that in now to be 11.18. So here we got 4, 3 times 5 is 200. And what's 40 times 11.18? 447.2.
Yeah.
447.
So we got 647 over 2. So 647.2 over 2. What's the final answer?
323.6.
323.6.